So everything that we've talked about up to this point regarding linear equations, solving systems of linear equations, substitution, elimination, all that stuff. We're going to use all those techniques in Newton talking about linear inequalities. So really similar, just a little bit different. But if you remember and understand all the previous videos on linear equations, you should have no problem. So we'll start with first graphing these things. And you can already tell, like, that looks a lot like, slope-intercept form. Y equals mx plus b. In fact, it pretty much is, except we have an inequality instead of an equal sign. So that's the only key difference. But graphing these things pretty much works the same way. So this is our slope, and this is our y-intercept. So if you remember, we'll start with our y-intercept. I'll plot a point there at our y-intercept. And the slope is 3, so m is equal to 3. I could also write this as 3 over 1, so we can see it as rise over run. So here's my starting point, that y-intercept. I'm going to rise 3 and then run 1. So 1, 2, 3, and then run 1. Plot a point there. Again, 1, 2, 3, run 1, plot a point there. And so with linear equations, we would just connect the dots, right, and have our line and be done with it. And we're pretty much going to do that here. Just a couple of things you want to keep in mind. If you see a greater than sign or a less than sign, your line is going to be dashed. Okay? If you see a greater than or equal to or a less than or equal to sign, your line is going to be solid. So here we have a just a greater than symbol. So this line is going to be dotted. So it'll look something like that. Okay, so that's the difference between the dotted and solid line. And then we choose a side of this line that we have now to shade. So since it's greater than, we're going to shade above the line. Okay, so what we're saying is any point in this shaded area, if we plug those points into this inequality, it will give us a true statement. So if I pick a point in this shaded region, let's say right here, that's going to be, 0, 2. Okay, so if I plug 0, 2 into my inequality up here, right, I will have 2 is greater than 3 times 0 minus 2. 3 times 0 is 0. And then minus 2. 0 minus 2 is going to be negative 2. And this here, 2 is greater than negative 2. That's a true statement. So this point satisfies our inequality, and it is one of many solutions that we could pick. But let's say I picked a point out here, not in that shaded region. So again, I'll do, this point we should call it, that's going to be 5, 0. I'll plug it back into this equation over here. We'll get y is greater than 3x minus 2. Y is equal to 0. X is equal to 5. 3 times 5 is 15, so 0 is greater than 15 minus 2. 15 minus 2 is 13. So we get 0 is greater than 13. And that is not true. So that's why this point here is not in our shaded region over there. So the point of graphing linear inequalities is just to show what range of values or what set of possible points, i.e. that shaded region, are going to be actual solutions to your linear inequality. All right, again, here we have our slope, which is going to be negative 1 over 2. And that's going to, that'll help us figure out how much to rise and run by. There's our y-intercept. So start at your y-intercept, so that's going to be right there. And then we're going to rise negative 1, so go down, and then run 2. So go down 1 and then over 2. Plot the point. Down 1 over 2. Plot the point. Down 1 over 2. All right, so since this is a greater than or equal to symbol, right, this line is going to be a solid line, okay? And since it's greater than, right, our range of solutions are going to lie above this line. You can pick any point in this area, including points along the line, because it's solid. If it was dotted like the last example, the points along that line would not be solutions to the linear inequality. Right, y is less than or equal to x plus 1. Remember, our slope is right there. It's the coefficient of the x. Since there is no number, we know that there secretly is a 1 there. So the slope is 1, or 1 over 1. So we can have our rise over run. Our y-intercept also happens to be 1, so we'll make that our starting point. And then we will plot all the other points using slope, rise over run. So we're going to rise 1, run 1. Rise 1, run 1. Rise 1, and run 1. And since it's y is less than or equal to, this line is going to be a solid line, not a dashed line. And since it's y is less than or equal to, this time we're going to shade below the line. So all of these points below the line are going to be solutions, as well as the ones actually along that line, because it is a solid line. Okay, y is less than 3/4 x. So we have our slope right here. So rise 3, run 4. And then even though we don't have a y-intercept there, we do, it's just plus 0. Just don't need to write it. So our y-intercept is there. So we'll start at our y-intercept, and then we're going to rise 3 and run 4. So we'll go 1, 2, 3, and then 1, 2, 3, 4. Plot a point. 1, 2, 3, 1, 2, 3, and then 4. A little bit off the graph there. This is y is less than, right? Just a single less than, not less than or equal to. So this is going to be a dashed or dotted line, however you want to call it. And since it's y is less than, the range of points that will satisfy this inequality are going to be below it, right? Below the line, not including the line. And I'll show you. Let's say why don't we pick 0, 0 right there? Plug it in to that inequality and see what happens. So I have y is less than 3/4 x, and we're using that point 0, 0. So y is equal to 0. 3/4 times 0, or 0 is less than 3/4 times 0. 3/4 times 0 is just 0. Anything times 0 is 0. And we have this statement now, 0 is less than 0, which is not true. 0 is equal to 0, but 0 is not less than 0. So that's why we have that dashed line, and points along that line will not satisfy the linear inequality. Okay, for this one, we can do it a couple different ways. You can use intercepts to plot your line, or you can convert this to slope-intercept form. So let's do that. Let's convert it to slope-intercept form. So what I'm going to do is I'm going to move some stuff around. I'm going to subtract 2x from both sides. That will go away. So we'll have negative 3y is less than negative 2x plus 15. Then I'm going to divide everything by negative 3. Those will cancel out. We'll get y is greater than or equal to, because when you multiply or divide with negative numbers, when you're dealing with inequalities, the sign will flip. So don't forget that. Keep that in mind. So here we will have positive 2/3 x, right? These negatives here, those will cancel each other out. And then 15 divided by negative 3 is going to be minus 5. So here is our slope. Nice rise over run form, rise 2, run 3. And that is our y-intercept. So y-intercept is going to be down here. We'll rise 2, and then run 3. Plot a point, rise 2, and then run 1, 2, 3. And it is, we're no longer dealing with that equation. We've converted it to look like that, so this is what we're going to go off of, right? So it's y is greater than or equal to, so this is going to be a solid line all the way through. And since it's greater than or equal to, your solutions are going to lie above that line. All right, last one here. Let's convert this again to slope-intercept form. So first, just get y by itself. What I'm going to do is I'm going to add x to both sides. I will get negative 3/4 y is greater than x plus 3. Excuse me, x plus 3 when I do that. And to undo this times negative 3/4 that's being done to the y, we're going to multiply by negative 4/3. And we're going to do that to everything. So I'm going to do times negative 4/3. So we'll distribute that into both of those on the right side there. What happens here is these terms cancel each other out. We are left with y is less than, right, because we multiplied by a negative number there, so we got to flip the sign again. And we'll get y is less than negative 4/3 x, and then negative 4/3 times 3 is going to be negative 4. So now this is the linear inequality we're going to use to graph. So start with your y-intercept. That's going to be at negative 4 there. And then we're going to rise negative 4 and then run 3. So we're going to rise 1, 2, 3, 4. It's a little bit off the graph, that's fine. And then run 3. 1, 2, and 3. Right there, if I want to kind of work backwards, I can rise positive 4. So 1, 2, 3, 4, and then run negative 3. So 1, 2, 3. This is y is less than all that stuff. So this is going to be a dashed line like that. And since it's less than, the points that are going to be solutions to this linear inequality are going to lie below that line.